like this screen with the reset button flashing, telling you that you have not reset the system. One of the first things that we're going to do is configure it. So we'll select the native units. You'll see you get a warning telling you not to use this selection to change between metric and English G-code. If you are a metric user primarily, set up your machine for metric. If you're a English user generally, then set it up for inches. You will never use this setting again. Once you set it, leave it alone and never change it. There are other ways to switch between English and metric for your G-code programs. If you change this setting, once you've set it, you'll have to retune your entire system. So pick a common use of your system and use that. I'm going to select millimeters because that is my normal use of my system. And we hit OK. Next step in configuration, in a general configuration, is ports and pins. You can see here that we have port number 378. That is a standard printer port address for port 1, and we have it turned on. Port 2 is turned off at the moment, and you probably won't use a second port. If you do, however, the addresses of the ports can be entered here and you can turn them on. If you use a port 2, you can also use pins 2 to 9 of that port as input signals in case you'd like to get more access to more inputs. Kernel speed should always be left on 25 kilohertz unless you have a system which requires excessive speed. 25 kilohertz is the least intrusive mode to your system, and it's highly recommended for all new users, irregardless of how much speed you need, to use 25 kilohertz. Now, you may have a system which does not have an address of 378 for your printer port. Most people do. To find the address of your printer port, you simply go to your control panel, system icon, select hardware, then device manager, and you'll see that under ports, your printer ports are listed. LPT1 is my first port. So if I do a properties of it and select resources, you can see that the address in the I/O range, the first number is 378. This is the number that you enter in that box. If you had a second printer port, such as I do here, with a Lavasoft parallel PCI card, LPT3, if I check its resources, you'll see that it is B000. So if we exit out of here and go back, I could turn on port number 2 and enter B000. You do not have to enter the 0x portion. The program will do that for you. And we hit apply. Over here on this side, you do have the choice of setting up a MACH CL or a MACH NC. If you do this, you don't need to set the pinouts for the motors. But these are only applicable to the MACH series. Leave them off otherwise. If you have a Sureline, select the half pulse mode. This stretches the mode specifically for Sureline products. Most do not need it and don't use it unless you have a Sureline. For Modbus input-output support and event-driven serial control, leave them off until you've hit a state of expertise in using Mach 3. They're not required unless you're using PLCs and other serial control equipment, and they will affect your system slightly in performance if you use them when you don't need them. Then we go to the motor outputs. In motor outputs, you should have a checkbox turning on each one of the motors you intend to use. You do not need a checkbox for the spindle unless you are going to use the step and direction or PWM options to drive your spindle. If you're driving a spindle that's simply controlled with a relay, you do not need to have spindle turned on. Hit apply whenever you make a change. Here you can see we have the step pin and direction pin of the x-axis. This information, which pins you enter in these boxes, should be an information provided to you by your CNC manufacturer. Whoever has built your table should have sent you a technical document telling you which pin controls which axis. In this case, you can see I've got the port selected is 1 for all settings. The step port is 1, the step pin is 2. So port 1, pin 2 is x-axis. Port 1, pin 3 is the direction control for the x-axis. When it comes to the settings for low active or not low active for a particular axis, you're better off leaving them unchecked until such time as you determine you have a problem. Many systems will run irregardless of these checkboxes. These are only necessary for some systems which are a little pickier as to whether the voltage is going high or going low at a time when the commands are being sent out. So all you have to set here is turn on your motors, set your pinouts, and then hit apply to store the results. Under input signals, for a basic setup when we're starting up, you don't want things interfering, so turn them all off with the exception of e-stop, which you cannot turn off. E-stop you can set to port 0 if you don't want it to affect you. Otherwise, set it to port 1. Pin 17 would be fairly typical. Pin 15 would be fairly typical, and will do the job for you. You can see that the active low is checked off, therefore a high signal is what is going to trigger an e-stop. At this point, you can pretty much stop using this configuration. Your primary task here in this setup is to get your motors running. So all you need is an e-stop signal, the proper motors turned on with the proper pins, and your port set up correctly. Beyond that, you don't need anything to get your motors to run, so let's hit OK and let things go. Now you can see that my reset button is flashing. If I push reset, it's still flashing, and I get a message, external e-stop requested. This is because of a change that we just made. Under ports and pins, input signals, you can see that the e-stop signal is checked so that it is an active high. If you don't connect a wire to a printer port pin, it will be high. Since we've selected active high, we're seeing a permanent e-stop condition coming into my printer port because I don't have a machine hooked up here. So by selecting this as active low and hitting apply, the e-stop signal will disappear, and you can see that although it's flashing, pressing it will reset it. You can always check to see if a signal is interfering with you by going to the diagnostics page, and if this emergency input was blinking, it means that the active low setting is set incorrectly and it is seeing an emergency stop. So now we have set up our motors and we want to move down. The next step that you need to do to get basic movement is motor tuning. So we'll go to the motor tuning stage. The first thing that's important is how many steps per unit it takes to move your table. As I said earlier, we set ourselves up for this machine in millimeters, so the steps per here refers to millimeters. Steps per millimeter, I have mine set to 2,000. If you don't know your steps per millimeter, we can calculate it out pretty easily, but use 2,000 as a start. Once you've set a steps per millimeter of 2,000, you need to test to see what acceleration and what velocity you're going to use. I should mention that before you start anything on this tab, hit the axis button that you're interested in. It brings up the stored results of that axis. So here we have the x-axis. We're going to set this as an example for the user to 1800 steps per millimeter. Once we change, anytime we change this steps per unit, we must touch the velocity and touch the acceleration sliders so that the system will recalculate its current settings based on its steps per unit. At this point, we can slide our velocity slider up and down to select different speeds. The speed is listed over here on the side in inches per minute or millimeters per minute, whichever you have selected. At the moment, mine says velocity in inches per minute, which is wrong. It is actually millimeters per minute, and that's a bug that I will have to add to my list for repair. If we slide to a particular speed and we want to know whether or not that speed is good, we can hit the up and down arrows on our keyboard right now while we're in this window. You can't see my motors moving here at the moment, but they are moving when I touch my up and down arrow keys. You want to adjust for a maximum speed, which is your G0 speed, which you're happy with. If you slide this slider to a particular speed, use your up and down arrows, and the motor sounds good, then that's a good velocity. You then want to grab your acceleration and move it up or down to select an acceleration that causes your motor to move without jerking. If it takes off smoothly and stops smoothly when we use the up and down arrow keys on the keyboard, then that's a good speed for your motor. Whenever you've done those few steps, hit Save Axis Settings to store them in memory. Then you could move on to the next axis, in this case the Y-axis, the Z, the A. The only buttons which will be lit are the buttons that you turned on in the ports and pins. If none of your buttons are lit, it means that you didn't select these axes in the setup of the ports and pins. Once all your speeds are set, you can exit this screen. The only other thing that I'll mention on this screen is step pulse and direction pulse width. These are the widths of your step and direction pulses. They are actually additions to the width. Step and direction pulses are typically approximately 1 to 2 microseconds long by default, and that's long enough for the vast majority of systems out there. If for whatever reason you find that your motors are not moving when you're using your up and down arrow keys, or they sound bad, you can use these numbers to increase between 0 and 5 the step pulse width or the direction pulse width. The only time you'll change a direction pulse width is if you find that you're losing 1 step each time you change direction. For 99% of users, you will never change this above 0. For 90% of users, you will never increase the step pulse above 0. Some controllers, however, do require up to 5 microseconds of additional step pulse width because the optocouplers in the drivers are a little slow, and this gives those optocouplers a longer time to adjust. So at this point, you should have basic movement. If you hit OK and exit out of that dialog, using the arrow keys on your computer now, you should see your axes jogging around. There are things that could stop that from happening, however. Pressing the Tab key on your keyboard will bring out the jog control tab. You'll see here a number, slow jog rate. It is currently set to 50%. If on your system it is set to 0%, then you'll get no movement. Typically this is set to 50%. And what that does is give you 2 speeds of jog. Just hitting the arrow keys on your keyboard, you can see I've got a speed of approximately 10 millimeters per second being fed. If I press the Shift key at the same time, I now go to fast jog, and I have 20, which is twice the slow jog. In other words, slow jog is 50% of the maximum rate, and you get the maximum rate by pressing Shift. Notice when I press the Shift key that the fast jog indicator lights up. Otherwise, you're on normal speed. The rest of the controls on this page you can pretty much ignore until you get more advanced. We have settings for the slow jog rate. You can increase it. You have buttons which will allow you to jog simply by pressing the button on the screen here. When it comes to the MPG modes and shuttle modes, we'll leave them off for now unless you get to the point where you're hooking up an MPG. An MPG is a manual pulse generator. It's an encoder which you can rotate and jog with the rotation of the encoder. It can also do other sharp features like shuttle mode, which allows you to run a program while rotating the wheel. The program actually runs at the speed that you rotate your MPG. You'll notice when I selected shuttle mode, our jog mode went over to MPG mode. Turning off jog mode, and we'll go back to the normal jog. So if you look at this screen, the second LED here should be lit, indicating that you're in normal keyboard jog mode, and you should have a jog speed at least around, well, let's put it this way, a jog speed above 5%, and you should see movement. Hitting the tab key will make that jog screen leave the screen. So at this point in the program, I can now jog, my motors are moving, and if you've tuned them properly, you should now have some pretty good movement with them. If you want to do a test to see how your system can respond, we can now just load a G-code file. If you select the Mach 3 folder on your system, there's a G-code folder, and once you select it, there are some test programs in there. This one is called Roadrunner, and will allow you to cut a test cut of a Roadrunner. When I hit cycle start to start the program will begin to move, and you can see that my speeds and feeds are probably not adjusted appropriately for this particular program, but eventually you'll see a green line trace out the path of the Roadrunner, and your motors should now be feeding themselves at that speed in that area. That's it for a general setup of Mach 3. For the beginning user getting their motors running, that should be all it takes.